Hi everyone, my name is Ali. I'm a PhD student within the Sesame program at UC Berkeley. I work with Professor Bob Full on the Eyes Toward Tomorrow program, and I'm going to be presenting today about an early technology-based intervention that promoted self-efficacy in students within our bioinspired design course. So to begin, here's a basic overview of what I'll be discussing. I'll begin first with this idea of research and teaching as a synergistic combination. And from there, I'll discuss how our design principles within this early makerspace experience were very much driven by students through assessment. I'll go over the actual early makerspace experience and what students did. I'll talk about how we assess students, what we asked of them, what educational outcomes we were interested in. And then from there, I'll conclude with this idea of a learning framework that's rooted in both the cognitive and affective domains. So to begin, I want to talk about this idea of research and teaching. And in order to give us a good understanding of that, let's look at this question of how much difference does it make when a student feels like they belong or don't belong in your classroom? And when I say belong or don't belong, what I'm referring to is this idea of sense of belonging, the feeling of acceptance by our membership in a particular community or group. And what I want to emphasize is that this matters in the lab and in the classroom. There's empirical research, both within the world of undergraduate education and within the world of graduate education, both related to learning outcomes within an undergraduate course and publication outcomes within research. That sense of belonging, it matters. Looking at the two publications that I'm referencing on the right-hand side of this slide here, talking about leaving, these two publications really shed light on the fact that even if students are academically successful, even if students are academically capable, they can and do leave STEM because of a lack of sense of belonging. And the same can be seen within graduate education, and thus the same can be seen within a lot of research. We have to view sense of belonging as a critical part to being a good researcher and to being a good student, to being a good learner and to being a good scientist, whatever it might be. Additionally, what I want to emphasize is that in both research and teaching, we have the following. We have to foster students' confidence or self-efficacy. Students need to feel like they are capable of doing something, and this confidence can be critical. And hopefully through this talk, I can show you that in the context of our 3D printing early makerspace activity. Additionally, what students know matters. They're certainly an important part of conceptual knowledge that drives a lot of the work within undergraduate education and within research as a whole. Conceptual knowledge matters. We have to know stuff. But also, how students feel matters, the affective side of learning. What are these feelings? These feelings include things like confidence, include things like sense of belonging, include things like self-efficacy. And without a true understanding of the affective side of learning, even the affective side of research, you're not going to get the full potential of people. In short, without recognizing these factors, we're going to miss out on the full potential of our students, both as scientists, researchers, and as learners within the classroom, right? This ends up being a critical part to really making sure that research and teaching are seen as inseparable. Moving forward, I want to now bring us into the context of the actual course. I'm going to focus on the creative design labs that we have within the course. So these are labs that are going to task students to create inventions with societal relevance. And so we do this through a scaffolded process in which we have students first complete 3 guided team design projects. They complete an early makerspace experience or the early technology-based intervention that I'll talk about. They complete a gecko-inspired adhesive design project and an origami robot design project, all of which are rooted within principles of bioinspired design so that they can complete an independent team design project that is a novel bioinspired design that they came up with, such as a muscle atrophy resistant cast inspired by the seahorse there. So now what I want to focus on actually is this first one, and specifically why it's first, right? It says early technology and early makerspace. There's a purpose to that, and that actually came from assessing students. And what I mean by that is that assessment drove the design of this activity. We asked students, what matters to you early on in this course? And they told us the makerspace. We wanted more access to a makerspace. We wanted an early makerspace experience. Looking at these two graphs, you'll see that students were unfamiliar with makerspace activities. They were unfamiliar with 3D printing before this assignment. This unfamiliarity is not conducive to a sense of belonging. It's not conducive to confidence. It's not conducive to cognitive nor affective success on the learning side. Thus, what we see very much through our assessment is that students wanted an early makerspace experience. So we made a purposeful decision to include this experience early on in their guided team design project trajectory. From there, we recognized that, of course, students' interest mattered, and their interest is what drove this early makerspace experience and its design. We wanted to focus on 3D printing because this is a accessible thing within our makerspace shown here on the right with the Ultimaker 3D printers, and wanted to promote students' confidence and ability or their self-efficacy. The reason why is because when you walk into a makerspace such as the one shown on the right, it can be intimidating. You see this big machine churning out all these 3D printed products. You're not sure if you belong in there. You're not sure if you're capable of doing that. We wanted to make sure students were capable of doing that and felt like they were capable of doing that and felt like they belonged. And in this whole process, we're leveraging the democratization of invention. And that's more broadly speaking within the maker movement. The idea that makerspaces are popping up left and right, that a lot of universities have makerspaces now. And we wanted to make sure that students who access these makerspaces feel like they belong within these makerspaces. And hopefully we can get that by fostering their confidence and ability or self-efficacy. So from there, what did we decide? We decided to create an early makerspace experience in which students 3D print and team assemble a prosthetic hand for children. We focused on the prosthetic hand for children because this was a 3D print that mattered. It was something that's of societal relevance. And research shows that students are doing things of societal relevance, their motivation is increased, their engagement is increased. And through that increase in motivation and engagement, we believe that confidence will develop. And when confidence develops, perhaps we can then break down this perception of not belonging to a technological community, like a makerspace. So we did this through our lab designers here, Ruby and Drew, who saw that here at Berkeley, the engineering department was actually focusing on this idea of Sophie's Superhand, a very important process in which we utilized the Million Hands project that resulted in Sophie's Superhand, an open source and accessible design for 3D printing hands that's for specifically children affected by this condition here. So this whole project, this whole print mattered in the sense that it was impactful to people who needed it, right? Now, from there, I want to recognize what made this activity unique. Thinking about the student themselves, what did they do? What was important to the student? Well, the student utilized an open source and accessible design. The eNable Phoenix Hand, which was a product of the Million Hands project, shown on the left in that figure there, this was very much open source and accessible. It was free. The design itself, anyone can download it. And it's easy to put into any of the 3D printing softwares that we utilize so that the students can all do this and do this with ease and access. This was scalable. We had to do this for 180 students. Every student 3D printed a prosthetic finger. And this was also empowering. Every student, along with their 3D printed finger, actually submitted a selfie in front of that 3D printer. We did this because we want students to see themselves as a part of the community, fully immersing themselves through this idea of taking a selfie. All in all, we feel that this very much made this activity 3D printing for all. Students from all backgrounds, students from all levels of expertise were very much being a part of this technological community. The sense of belonging was starting to be fostered. From there, we asked them to, of course, submit their selfies. Here are their selfies, them relishing in their success here. And so now, once they have this individual print done, we wanted the team process to also be a big part of this activity. So what students did after they 3D printed their finger was they collaboratively assembled the entire prosthetic hand. They created a fully functional final product, and that fully functional product helped them see what this activity was all about. They maneuvered with the hand, they tried to pick up things, they tried to see what it was like, imagining themselves within it. And then we utilized some post-activity discussion questions that went beyond just the content. And what I mean by that is this first question here very much is a content-based question. It's a conceptual question. And I recognize that this is important. This is an anatomy-based question, sort of a physiology-based question. And that's critical. We want students to do that in a bioinspired design course. But we also want students to think of large-scale affective outcomes, large-scale feelings about societal impact. And that's what that second question is really getting at. So we really tried to combine both of those things and go beyond just the content by creating both a cognitive and affective side of learning here. Here they are in their success, again, relishing as they completed the entire build with a fully functional 3D printed hand for children. And now, in terms of the educational assessment, what did we do as the educational researchers here? Well, we focused on design-based research in which we had an iterative, responsive, and feedback-based approach. We had cycles of change in which we had theoretical understanding of what we wanted, self-efficacy, confidence, sense of belonging. And we tried to make sure that we're fostering that within each cycle of change, whether it was through adding discovery-based questions, such as the ones that I showed before, adding cognitive and affective questions, such as the post-activity discussion questions, whatever it might be, we wanted it to be very much in the design-based research realm in terms of our methodology. We wanted to rethink assessment. Students have agency, their voices matter. Their voices are very much what's driving a lot of our design within this activity. And we also wanted to make sure that we were assessing this big component of self-efficacy, right? We wanted confidence and ability to be top of mind for us. And so we did that through a before and after intervention, also asking about future perceptions. I do want to recognize that there are certainly challenges to this approach, self-reported data, using Likert scales, but in future approaches, we do want to go deeper. We want to interview students and actually look at the more, the affective side of learning in an even deeper approach than just survey-based assessments with Likert scales. So what did we see? Our results showed that students certainly felt more comfortable about using makerspace equipment after this assignment. Resoundingly, we see 4s and 5s here. More comfortable, again, is a proxy of self-efficacy, of confidence, right? And then also we saw the following. We saw that students were more interested and more confident in learning about other makerspace activity, other makerspace equipment. This clearly showed to us that students felt a sense of inclusion and belonging to a technological community based off of the results from this survey-based assessment that we gave them. Now, the next step, students also indicated to us that they're interested in designing their own 3D prints. And again, that is also a proxy of self-efficacy. Not only do they want to print, they now want to design their own stuff because they're so comfortable with the idea of printing, 3D printing in and of itself. So all of this hopefully can be rooted within the following learning framework. Cognitively, what students know matters. This is critically important. Conceptual knowledge is important. I totally recognize that we have to make sure that students know certain things. And that's usually our typical focus, and we do a good job of that within undergraduate STEM education. But we also want to focus on the affective side of learning, how students feel. That matters too. Their emotions, psychosocial variables like self-efficacy and sense of belonging, we cannot forget this. And instead of viewing these two as separate, let's view them together. Let's stop thinking of these two as mutually exclusive or dichotomous and recognize that there's certainly an interplay. And that interplay, that sort of intersection is when we get the best learning outcomes, is when we get truly the best success when it comes to this type of learning environment. So overall, and in conclusion, I believe that enhancing courses by focusing on students' sense of belonging, self-efficacy, and both cognitive and affective outcomes is certainly going to translate into success in both research and teaching. Thank you.